Hello, engineering enthusiasts and curious minds. Today, we're diving into the fascinating world of material testing in construction. It's something we don't often see, hidden beneath the surface of the impressive structures that grace our skylines. But trust me, it's crucial. Imagine building a skyscraper that reaches for the clouds or a bridge that spans a mighty river. We're talking massive structures that rely on the strength and durability of their materials. That's where material testing comes in. It's the unsung hero of construction, ensuring that every beam, column, and foundation can withstand the test of time. It's not glamorous, but it's absolutely essential. Without it, we risk catastrophic failures that can cost lives and cause widespread damage. Remember the saying, an ounce of prevention is worth a pound of cure? That's material testing in a nutshell. So buckle up as we explore the fascinating world of material testing and discover how it keeps our built environment safe and sound. Let's face it, buildings are heavy. They're subjected to incredible forces, from their own weight to the relentless pull of gravity to extreme weather events like hurricanes and earthquakes. And let's not forget the wear and tear of everyday use. Material testing is our first line of defense against potential disasters. By identifying weaknesses and ensuring that materials meet the required standards, we can prevent catastrophic failures. We're talking about bridges collapsing, buildings crumbling, and tunnels caving in. The consequences are unthinkable. But it's not just about preventing the worst-case scenario. Material testing also plays a vital role in extending the lifespan of our structures. By identifying potential issues early on, we can implement preventative measures that save time, money, and resources in the long run. Think of it like this. Would you rather spend a little extra on regular car maintenance or risk a major engine failure down the road? It's the same principle with buildings and infrastructure. Material testing is an investment in safety and longevity. It's about building structures that stand the test of time. Now that we understand why material testing is so important, let's meet the usual suspects, the materials that form the backbone of our built environment. First up, we have concrete, the workhorse of construction. From towering skyscrapers to humble sidewalks, concrete is everywhere. Next, we have steel, the strong and silent type. It provides the skeletal framework for many modern buildings, giving them incredible strength and stability. Think of steel as the superhero skeleton holding it all together. But we can't forget about the ground beneath our feet. Soil, often taken for granted, plays a critical role in supporting our structures. Understanding its properties is essential for designing safe and stable foundations. Last but not least, we have aggregates, the unsung heroes of construction. These seemingly insignificant particles of rock, sand, and gravel are essential components of concrete and asphalt, providing bulk and strength. Each of these materials has unique properties that must be carefully considered during the design and construction process. And that's where the magic of material testing comes in. Let's start with concrete, shall we? It's a fascinating material. A mixture of cement, water, aggregates, and often a dash of admixtures to enhance its properties. But how do we make sure that the concrete we use is up to snuff? One of the most common tests is the slump test. It's as simple as it sounds. We fill a cone-shaped mold with fresh concrete, lift the cone, and see how much the concrete slumps. It tells us about the concrete's workability or how easy it is to pour and mold. But the real test of concrete's metal is its compressive strength. This is where things get serious. We take cylindrical concrete samples, cure them carefully, and then crush them in a giant press. The pressure required to crush the concrete tells us how strong it is. Of course, concrete needs time to reach its full strength, and that's where curing comes in. Think of it as providing the perfect environment for concrete to harden and gain strength. And let's not forget about durability. Concrete must withstand the test of time, resisting the elements and the wear and tear of everyday use. Let's talk about steel, the backbone of modern structures. This iron and carbon alloy is known for its strength and versatility. Before use, steel must pass rigorous tests. The tensile strength test pulls a steel sample until it breaks. It measures the pulling force the steel can withstand. The bend test checks if steel can bend without breaking. We bend a sample and check for cracks. The impact test drops a weight on steel to test resistance. This is crucial for structures in earthquake-prone areas. Let's dig into the world of soil testing. Understanding soil properties is crucial for safe foundations. The Standard Penetration Test, or SPT, is common. It involves driving a sampler into the ground with a hammer. This assesses soil density and bearing capacity. The Proctor Compaction Test shows how densely we can compact soil. Compaction ensures a stable base, preventing settling and structural issues. The Soil Shear Test measures internal friction and cohesion. These properties are essential for preventing landslides and ensuring stability. Soil testing is essential for designing safe foundations. Aggregates, the unsung heroes of construction. Aggregates play a vital role in construction. These particles form the bulk of concrete and asphalt, providing strength and stability. Material testing ensures their quality. Sieve analysis determines particle size distribution. Abrasion tests measure resistance to wear. We don't want our roads crumbling under traffic. Specific gravity and water absorption tests reveal density and porosity. Aggregates may be small, but their impact is huge. Careful testing ensures the longevity of our structures. Section 8. Meeting the mark standards and certifications in material testing. In the world of material testing, precision and accuracy are paramount. That's where standards and certifications come in, providing a universal language and ensuring that materials meet the required quality and safety benchmarks. Organizations like the American Society for Testing and Materials, ASTM, the American Concrete Institute, ACI, and the International Organization for Standardization, ISO, play a vital role in developing and maintaining these standards. They provide a framework for conducting tests, interpreting results, and ensuring consistency across the industry. These standards cover a wide range of materials and testing methods, providing clear guidelines and specifications. They ensure that materials are tested under controlled conditions using standardized procedures so that the results are reliable and comparable. Certifications, on the other hand, provide independent verification that materials or products meet specific standards. This gives consumers and regulatory bodies confidence in the quality and safety of the materials used in construction. Think of standards and certifications as the guardians of quality control, ensuring that the materials used in our buildings and infrastructure meet the highest standards of safety and performance. Section 9. The future is now innovations in material testing. The world of material testing is constantly evolving, with new technologies and innovations emerging to improve accuracy, efficiency, and sustainability. Let's take a peek into the future, shall we? One exciting development is the rise of non-destructive testing, NDT methods. These techniques allow us to assess the properties of materials without damaging them, saving time, money, and resources. Imagine using X-rays or ultrasound to peer inside concrete structures, or employing ground-penetrating radar to map underground utilities without breaking ground. Another game changer is the use of digital twins, virtual representations of physical assets that can be used to simulate real-world conditions and predict material behavior. This allows engineers to optimize designs, predict maintenance needs, and extend the lifespan of structures. And let's not forget about the power of artificial intelligence, AI, and machine learning. These technologies are transforming material testing by automating data analysis, identifying patterns, and providing real-time insights that were previously impossible to obtain. The future of material testing is bright, with innovations that promise to make our built environment safer, more efficient, and more sustainable. Section 10. Building a safer tomorrow, the enduring importance of material testing. As we've discovered, material testing is an indispensable part of the construction process, ensuring the safety, durability, and longevity of our built environment. From the towering skyscrapers that grace our cities to the bridges that connect us, material testing plays a silent but vital role in our daily lives. By understanding the properties of materials and identifying potential weaknesses, we can prevent catastrophic failures, extend the lifespan of structures, and create a more sustainable future. Standards and certifications provide a universal language and ensure consistent quality, while innovations in testing methods are pushing the boundaries of what's possible. As we continue to build higher, longer, and more complex structures, the importance of material testing will only continue to grow. It's an investment in our safety, our future, and the legacy we leave behind. So, the next time you marvel at an architectural wonder, take a moment to appreciate the hidden heroes of material testing who made it all possible.